So what we're checking here to see if a line runs through these 2 points is also having that one on the same line, is we're checking to see if they're collinear. So we're going to check the first 2 points, and we're going to do y2 minus y1 and x2 minus x1. So we're getting -6 or +6 over -6, which is -1. So to check if that one is collinear, we just have to check it against one of these 2 points. So we can check to see if this one is collinear to this one, for example. So y1 or y2 minus y1 over x2 minus x1. So I'm getting +3 over -3, which is -1. So as soon as you realize that this point and this point have the same slope as the red 2 points, these are the same slope, you can actually say that yes, they are collinear, because you only have to check 2 of the slopes between the 3 points to know if the 3 are collinear. So this one also does lie on the line. This example asks, what does it mean if a line doesn't have an x-intercept? So if I were to draw a Cartesian plane here, here's the x-axis, here's the y-axis. If I draw a line usually, any kind of slanted line, it's going to have an x-intercept and a y-intercept. Maybe they won't be on screen, but eventually you're going to hit that. So even if it looks like this, it looks like it never hits the y-axis, but you know it does if the line just keeps on going, right? And even if it hits right here, and the x-intercept is 0, 0, still exists, the x-intercept is 0, 0, and so is the y-intercept. So in any kind of line with any kind of slope like this, you are going to have an x and a y-intercept. It just eventually will hit those axes. The only way to not have a y-intercept is if you have a vertical line like this, and it's perfectly vertical. So a vertical line never touches the y-axis. So there is no y-intercept for a vertical line. If you look at any kind of horizontal line, a horizontal line has a y-intercept, but it never touches the x-axis. So a horizontal line has no x-intercept, but it does have a y-intercept, right? So if a line doesn't have an x-intercept, then it must be horizontal. And if a line doesn't have a y-intercept, then it must be vertical. If a line doesn't have a slope, we would say that the slope is undefined. A slope undefined means that it is vertical. But that's not the same thing as saying that the slope equals 0. If the slope is 0, it has a slope. The slope is 0. This means that the line is horizontal. The important take-home message from this is, do you remember how to write the equation of a line if it's vertical or if it's horizontal? So for example, if this point here is 6, 0, what is the equation of the black line? And you would have to recall that the equation of the black line is x equals 6. It has an equation. It's called x equals 6. And if you have it hitting the y-axis at 6, you would say that this blue line has an equation of y equals 6. It has an equation, just looks kind of weird. The equation is y equals 6. So just remember what equations look like for vertical lines and horizontal lines. So we're asked to write an equation of a line in this slope point form. This one right here. And they give us a point, which is very helpful. So in theory, we could write, this is x1 and this is y1. So we can write most of this equation just right off the bat. Like we could write y minus y1, which is +2, is equal to m and then x plus x1. So you have to realize that in slope point form, you can plug in the point that they give you. Whatever point they give you, you can plug that in for y1 and x1. And just be aware that this is a minus. So if there's already minuses here, then they turn into pluses, like so. The tricky part about this question is they haven't given us a slope. So we don't know what m is. All they've given us is a clue about m. They've told us that the line is parallel to this line. So if I were to draw that line, y equals x plus 3, it has a y-intercept at 3, and it's got a slope of 1. It's not written there, but it's got a slope of 1. So what that means is that if our blue line is parallel to it, see we have -1, -2. If it's parallel to it, it's going to look something like this. There's our blue line. And so the slope of the blue line is the same as the slope of the red line. That's what parallel means. So if they're the same, then we know that the slope of the blue line must also be 1. So instead of writing m, we just need to write 1. And here's our answer, the answer to part A. We have written the equation of the line in slope point form. The hard part about B is interpreting what this means. This x equals 5. Is this even an equation of a line? It doesn't look like y equals mx plus b. It doesn't look like this. Is this an equation of a line? And you have to remember that actually, yes, there is such a thing as a line of x equals 5. It's just that this line is a vertical line. This is the equation of a vertical line. So we are looking for a line that is perpendicular to this one and runs through the point -1, -2. Here's the point -1, -2. And if we want a line that is perpendicular to the purple one and runs through this point, we're essentially asking for this line here. A line that is perpendicular to a vertical one is a horizontal line. So we're looking for a horizontal line that runs through this point. So remember that the format of a horizontal line is y equals something. And what does that y equal? Well, what does the y equal here? It's -2. And that's the equation of a line that runs through this point and is perpendicular to a vertical line. A line through 5, k and -3, 1 has a slope of 4. What is k? So remember, for the values of k1s, you just have to pretend like we have it and start putting it into equations. And then we solve for k. So here's x2, y2. So to find the slope, you're going to have to do y2 minus y1. So 1 over k, or 1 minus k, over x2 minus x1. And that's supposed to be equal to 4. So let's see if we can work out what k is. So 1 minus k over -8 is equal to 4. I will kill off my fraction by multiplying both sides by -8. So we have 1 minus k is equal to -32. I can subtract 1 from both sides to make it -k is equal to -33. But they're both negative. We can't leave it like that. We got to multiply both sides by -1. So k is equal to +33. So there is an easy way to do this and a hard way to do it. We've been given two slopes, and we're being told that they're perpendicular, and we're trying to find k. So if you're smart about this, you'll realize that you can flip and make -1 of the slopes and then set them equal to each other. Why? Because they're perpendicular. So right now, if we were to write it like this, set them equal to each other, this is not correct. Because if they're perpendicular, that does not mean they're equal. If it said they were parallel, then I could write this, but it says they're perpendicular, which means to make them equal, I have to actually flip one and make it negative. You can choose which one you want to flip and make negative, but if you're smart about it, you will flip this one and make it negative for two reasons. Firstly, then you get rid of the negative, which is great. And secondly, then we have k upstairs, and that makes our lives much easier. Because once we have that, we can solve for k. And this solving is pretty easy. K is 6/5. So we have a slope with a piece that's unknown, but what we know is that it is parallel to this line. Unfortunately, this line is in general form, which means that you cannot simply read the slope off of this line. You actually need to convert it to y equals mx plus b. Otherwise, you cannot read the slope. So we're going to try and isolate for y. So I'm going to move the x and the 4 over to the other side. So -2y is equal to -x minus 4. Then I'll divide everything by -2. and I'll be left with y is equal to 1/2 x plus 2. So there is my line in a form where I can actually read the slope. But the only thing I care about is the slope because this was parallel to this line. So I only care about the slope of it. So if this is the slope of the blue line, then this slope, which is parallel to it, must be equal to that slope. And then we can multiply both sides by 3 and realize that k is equal to 3/2. And we're done.